We need to talk about something that's been bothering me for months. I've been watching indie hackers and startup founders frantically cobbling together tech stack with Redis for caching, RabbitMQ for queues, Elasticsearch for search, and MongoDB for any other reasons. I'm guilty of this too. When I started building my own SaaS app, my first instinct was to plan out a proper architecture with separate services for everything. Then I stopped and asked myself, what if I just used Postgres for everything? Turns out there is this elephant in the room that nobody wants to acknowledge. Postgres can do literally all of this, and it does it better than you think. The Postgres can scale myth that's costing you money. Let me guess. You have been told that Postgres is just a relational database and you need specialized tools for specialized jobs. That's what I thought too, until I discovered that Instagram scaled to 40 million users on a single Postgres instance. Discord handles billions of messages. Notion built their entire product on Postgres. But here's the kicker. They are not using Postgres like it's 2005. Queue systems. Stop paying for Redis and RabbitMQ. Postgres has native support for listen and notify, and can handle job queues better than most dedicated solutions. Simple job queue in pure Postgres. ACID compliant job processing. This gives you exactly once processing with zero additional infrastructure. Try doing that with Redis without pulling your hair out. In my own SaaS app, I use this exact pattern for processing feedback, submissions, sending notifications, and updating roadmap items. One transaction guaranteed consistency, no message broker complexity. Key value storage. Redis costs $20 a month minimum on most platforms. Postgres JSONB is included in your existing database and does most of what you need. Your Redis alternative, GIN index for blazing fast JSON queries, query nested JSON faster than most NoSQL databases. The @greater operator is Postgres' secret weapon. It's faster than most NoSQL queries and your data stays consistent. Full text search. Elasticsearch clusters are expensive and complex. Postgres has built-in full-text search that's shockingly good. Add search to any table, auto-update search index, ranked search results. This handles fuzzy matching, stemming, and relevance ranking out of the box. For my own SaaS app, Feedback Search, this lets users find feature requests instantly across titles, descriptions, and comments. No Elasticsearch cluster needed, just pure Postgres doing what it does best. Real-time features. Forget complex WebSocket infrastructure. Postgres Listen and Notify gives you real-time updates with zero additional services. Notify clients of changes. Your application listens for these notifications and pushes updates to users. No Redis pub and sub needed. The hidden costs of specialized tools. Let's do some math. A typical modern stack costs Redis $20 a month, message queue $25 a month, search service $50 a month, monitoring for 3 services $30 a month. Total we got $125 a month. But that's just the hosting costs. The real pain comes from operational overhead. 3 different services to monitor, update, and debug. Different scaling patterns and failure modes, multiple configurations to maintain, separate backup and disaster recovery procedures, different security considerations for each service. Next, we have the development complexity, different client libraries and connection patterns, coordinating deployments across multiple services, inconsistent data between systems, complex testing scenarios, different performance tuning approaches. If you self-host, add server management, security patches, and the invitable 3 a.m. debugging sessions when Redis decides to consume all your memory. Postgres handles all of this with a single service that you're already managing. The single database that scales. Here's something most people don't realize. A single Postgres instance can handle massive scale. We are talking millions of transactions per day, terabytes of data, and thousands of concurrent connections. Real-world examples: Airbnb, single Postgres cluster handling millions of bookings. Robinhood, billions of financial transactions. GitLab, entire DevOps platform on Postgres. The magic is, in Postgres' architecture, it's designed to scale vertically incredibly well. And when you finally need horizontal scaling, you have proven options like replicas for query scaling, partitioning for large tables, connection pooling for concurrency, logical replication for distributed setups. Most businesses never hit these limits. You're probably fine with a single instance until you're processing millions of users or complex analytical workloads. workload. Compare this to managing separate services that all scale differently. Your Redis might max out of memory while your message queue struggles with throughput and your search service needs different hardware entirely. Stop over-engineering from day one. The biggest trap in modern development is architectural astronauting. We design systems for problems we don't have, with traffic we have never seen, for scale we may never reach. The over-engineering cycle. We might need to scale someday, add Redis queues, microservices, multiple databases, spend months debugging integration issues, launch with 47 users, pay $200 a month for infrastructure that could run on a $5 VPS. Meanwhile, your competitors ship faster because they are not managing a distributed system before they need one. The better approach: start simple with Postgres, monitor actual bottlenecks, not imaginary ones, scale specific components when you hit real limits, add complexity only when it solves actual problems. Your users don't care about your architecture, they care about whether your product works and solves their problem. When you actually need specialized tools. Don't get me wrong, specialized tools have their place, but you probably don't need them until you're processing over 100,000 jobs per minute. You need sub-millisecond cache responses, you're doing complex analytics on terabytes of data, you have millions of concurrent users, you need global data distribution with specific consistency requirements. Why this actually matters? Here's what blew my mind. Postgres can be your primary database, cache, queue, search engine, and real-time systems simultaneously, all while maintaining ACID transactions across everything. One transaction, multiple operations. Try doing that across Redis, RabbitMQ, and Elasticsearch without crying. The boring technology that wins. Postgres isn't sexy, it doesn't have a flashy website or viral TikTok presence, but it's been quietly powering the internet for decades while other databases come and go. There is something to be said for choosing boring, reliable technology that just works. Action steps for your next project. Start with Postgres only. Resist the urge to add other databases. Use JSONB for flexibility. You get schema-less benefits with SQL power. Implement queues in Postgres. Save money and complexity. Add specialized tools only when you hit real limits, not imaginary ones.